Hi, this is the project that I wanted to show off as one of my favorites, as something memorable. Um, I've written an evolutionary neural network from scratch, and then I've also implemented it in order to, show off that it works. Before I show it off, I'm going to just switch over to the actual program. Um, First of all, it is very inefficient as I started writing this in the last years of high school before I knew about matrices. And if you look over here, there's a lot of classes that could have just been matrices. So my next step is actually rewriting all of this to be implemented as just numbers instead of all of this useless abstraction, because this is slowing it down by a lot. However, it is completely written from scratch. Everything, including the evolution, the random biases, the generation of the networks themselves, everything. And I've also made it very generalized, so that it can really be connected to anything. And I did that with lambdas essentially. Um, so if we go over here, you'll be able to see that I'm going to slow this down. I open up any map view. I've got a bunch of saved maps over here, and I generate a bunch of checkpoints, and we let the cars go at it. The current inputs that these objects have is they raycast in a bunch of directions, and the return is the distance to the wall. And based off of just that info in about 8 directions, I'm hoping that it can learn to drive. And I'll speed this up again just for a little bit. So you can see at the start it's pretty random, but immediately you can already see that they begin to make more progress. And you can see this one right here. These are the blue lines are what you can see as its inputs. So I only draw the blue lines for the best one from the last generation. Now I'll let this run so you can see that it does work. Alright, so I think you get the gist of how this program runs. We had one that plateaued, like this program plateaued for a while, and it found kind of like a local maximum for how efficient it could run this track. And something that I implemented within my base neural network class is that if it finds that it plateaus, it slowly increases the rate of mutation, which is where the evolutionary network comes in, and it'll keep increasing the level of mutation until it is able to branch out and find another um, network that is as efficient or more efficient than the current one. And by doing that, it can hopefully find an even higher maximum. And you can see right here, this is outputting the scores, which is based on a fitness function, which I write within this class right here. This is the average speed, how many checkpoints and laps it went through, and it also outputs the entire network right there, all of the nodes, weights, everything. So if I wanted to test it, I could test it directly here. One of the things that optimized in this second one right here, you can see it's ever so slightly better than the last one, was its speed, because this simulation does include a little bit of drifting. And so the ones who are able to take the corners better are obviously going to be a little bit faster and are going to perform better. This, again, is written to be as super general as possible. So I'll show you over here. The way that this car is created is with a bunch of inputs, and these inputs can literally be anything. In here, it gets the distance from in a certain direction to the closest wall, but it could be anything. It could be reading off of a certain pixel in a picture, or anything of that sort. Again, the outputs are also lambdas, so in this case it just changes its speed and direction directly, and the rest of this control is within the other general class. I'm actually very proud of this program, and I'm hoping that I can make it more efficient so that I can do other things like recognize numbers and whatnot. And yeah, this is something memorable.